it's completely fine. Most of you know, I mean, though you might have not done an hands-on session on Docker, but most of you know what is meant by a container and how it runs and what's the difference between a container and a VM. So you can get some basic kind of the concepts which we are going to discuss as of now in this session. So let's get started with. So before we start, just to give you a kind of notification that I'm going to start, I'm going to record this particular session so that we can put it on in our Slack channel. Okay. To get started with, so we all know, like, we are going to have a session on this Kubernetes. So basically Kubernetes, it's like, you know, best in the planet. It is basically a kind of an orchestration kind of an engine. It is used to deploy a scalable kind of application into your server farm. So that server farm can be either cloud or it can be your on premises servers, right? So on and so forth. So basically Kubernetes gives you a kind of a facility to orchestrate and cluster your applications into multiple nodes. And that node, you know, it can be either a VM, a virtual machine, or a bare metal server, or a cloud server, or an OpenStack server. It's your choice how you have to use it. Right. So basically this Kubernetes was basically a project used by Google. Google used to distribute its workload into its own server farm by using I mean, it was basically using this Kubernetes. The name was a bit, you know, a bit different than it, but they were using this particular Kubernetes in their own applications like Gmail and Google Drive and so on and so forth. So they used to distribute the loads into the cloud by using this Kubernetes. And since 2010, they have, you know, open sourced it. So you can also use Kubernetes for free, and you can just try to, you know, try to just customize it as per your own need. Like you guys might have seen various, you know, cloud platforms like AWS or Google Cloud or Azure. They have their own versions of their Kubernetes kind of deployments. And that's because you have the power of open source, where you can use the default functions of this Kubernetes and try to just customize it for the cloud-based kind of the connectors and so on and so forth. So those are the things. So what we will do is we will get started with the basics about this Kubernetes. And if you have any questions in between, you can just try to ask by just turning on the mic, and I'll just be glad to answer those questions. Okay. So one of the question is, which has been posted by Mr. Manoj, is, so it can be Docker one. So basically, Kubernetes is an orchestration engine. It started by default with Docker, but there are various other, you know, container executions which can also be done. So besides Docker, like one of the famous container engine as of now is Rocket. So if you want to deploy those kind of loads or those kind of the containers in this Kubernetes, of course you can do it. So Kubernetes comes with batteries included. By default, it is Docker, but if you want to change the container runtime, you can do that. I hope that, you know, answers your question, Manoj. Okay, so let's get started with this. So I have just made a Trello board. What I'll do is I'll just make this board public at the end of this session. Let me do it as of now so that you can also use it. And I'll just copy the link of this board into the chat section. So if you want to just try to just refer this board, you can do it. And I'll also post it in our Slack channel as well as our this meetups. Okay. So what basically you can do with this Kubernetes? So to do that, I mean, to explain that, I'll just come back to like one of the examples which we did in our last session. If you were there in the last session, it would be easier for you to relate. If you are not there, it's fine. You can just try to grasp up what I'm trying to say over here. In the last meetup, what we did was we had made a swarm, right? We had made up a swarm, a Docker cluster, where you had couple of master nodes and you had couple of this worker nodes, right? And what we did then, is that we deployed our loads over here. So we had tried to deploy app1 over here, and since it was a cluster, it was basically kind of replicated over here. Okay, somebody's asking me to put it full screen. Is this better now? Yes. Okay, thanks. So what we did was we made a kind of a cluster over here of applications. And what we tried to do is we did a kind of a load kind of a balancing between these applications. And what happened was, if we tried to hit one of the IP addresses from this swarm, it would do a kind of a load balancing between this applications, and then that's how we used to deploy our clusters, right? So basically, the whole purpose of Docker Swarm as well as this Kubernetes is to orchestrate your applications to multiple nodes or multiple virtual machines or your multiple different instances, and to have a kind of a scalability and kind of a high throughput of your applications. We had seen in our last session, we tried to put a load into one application for 1,000 requests with 4 of the requests per second. And then we had switched to this multiple applications, and we could see the effect. We could see the high throughput which we used to receive in case when we had distributed the load to this multiple nodes, right? So in the similar way, this Kubernetes is a high level kind of an orchestration engine. And it has a kind of a lot of things into its architecture, but it's not completely visible in front of you when you try to deploy your workloads. It's quite a kind of a subtle thing. If you will write some of the commands, you will not try to understand what is actually happening in the background. But it's quite important for you to understand what is there in the background, so that when you execute your applications, you will be able to understand how it got executed. Okay, so let's try to jump in with the basics. So this entire this Kubernetes is based on the concept of 2 things. So this Kubernetes has 2 different types of the processes. First process is the master process, and second process is a node process. Okay, so these are 2 types of the processes which we have. Just a second. Okay, so we have 2 different types of the processes. As the name suggests, the master process is actually responsible to schedule the jobs and to maintain the state of the cluster, so on and so forth. Nodes are the people who, nodes is an kind of an a kind of a node is kind of a machine or a virtual machine or a like a bare metal server, which is going to execute your job, right? So masters and nodes basically are platform agnostic. So they basically can be bare metal or VM or cloud or OpenStack, right? So that's the kind of a scalability which you can have. So you can deploy this Kubernetes into all 4 different types of platforms. It actually doesn't matter whether you are executing this Kubernetes into a bare metal or into your AWS cloud, right? It is going to function in the same way in all the 4 different types of platforms. Okay, so what you can try to just consider is you have a master node which is going to take care of the scheduling and maintaining the state, and you have these nodes which are going to take care of about execution of the jobs, right? So that's the two basic type of the processes which is going to be there in this Kubernetes. Now let's deep dive into master. What does master have? Like, what is the what are the different kind of the processes which runs inside the master? So basically you have these four basic type of the objects in case of master, right? So if I just open up the diagram, so let's say this is the master node, okay, and this master node contains these many type of objects. First is the API server. So basically your entire this Kubernetes is based on this API server, because what is going to happen is your API server is going to take the kind of the manifest file. It is going to see the description about the distribution of loads, and it is going to execute that particular distribution of nodes into the cluster, right? So that's how it's going to execute. So if you can just try to recall, in case of Docker, we had a kind of a Docker daemon, and Docker daemon also used to run on top of an API server. So if you fire a kind of a command on the command prompt, it's basically going to call that API server. So it's going to execute all the commands on top of this API server. So the role of this API server is to actually get the kind of manifest file and execute the instructions written on the manifest file, right? So let's go through all the components. So like I said, API, Cube API server is a process which is there on the master node. You won't find this particular service on the nodes, on a simple node, but it is on a master node. And it acts as a front end to the control plane. So basically your masters and your nodes are going to be connected and controlled over something known as KCP. The meaning of this KCP is Kubernetes control plane. Okay, it's a kind of a channel which maintains a kind of a communication between your master node and your rest of the nodes. Okay, so this API server exposes the API, which is going to process the manifest file, which we are going to throw it up to the API server. And it is going to actually validate it from the perspective of master, and then it is going to deploy the task and the containers to the clusters. Okay. Next component is cluster store. So in the last session, when we were discussing about Docker Swarm, we were also speaking about a desired state and to maintain a kind of a desired state. So let's say 4 different clusters of application 1 into Docker Swarm was a kind of a desired state in our last discussion, right? So that state is known as a desired state, right? So basically that state has to be stored somewhere, because this is a kind of a distributed thing. You have multiple nodes at place, right? So where do we store that state? So that for that you have something known as cluster store. Cluster store basically offers you a persistent storage of the cluster state and configuration. It uses something known as etcd. So etcd is a kind of an open source distributed key value store, and it was developed by the developers of the Core OS, right? So basically it tries to maintain the state of your this Kubernetes cluster in a kind of a distributed fashion, and it also tries to just actually manage the consistency of it. Okay, so this cluster store is a kind of a single source of truth for a cluster. Like whatever is the state is defined, it is stored in this single source of truth that is known as cluster store. Next, we have something known as Kube Controller Manager. So it tries to actually manages different kinds of things like this node controller. It also has something known as endpoint controller. It has something known as namespace controller. We'll try to just discuss most of this when we will come to it. But that's a kind of a broad level kind of architecture which you should keep into mind. Okay, and we have something known as scheduler. So this is the component which is going to schedule and assign the work or the container to the nodes and the pods, right? So this is what is the task of this kube scheduler. So basically coming back, you have masters and nodes, and you have something known as masters, inside which you have these many components. First is the Cube API server, which is the API endpoint, which is going to take the particular manifest file. It's going to create a cluster and distribute the processes based on the things which is written in the manifest file. You have something known as cluster store, which is going to persist the desired state of the cluster. You have something known as Cube Control Manager, which is going to manage different nodes and watch for the actually changes in the structure. And this is the component which is going to maintain the desired state. And you have something known as Cube Scheduler, which is going to assign a particular task or a particular job to a given node or a pod. Okay. So this is the kind of a bird's eye view above API controller. API server is exposed externally, right? So whatever kind of a communication is happening to the Kubernetes, to the external world, is happening via the API server. So API server is the one which is going to do the orchestration to the controller manager, to the cluster store, to the scheduler, so on and so forth. I have a question over here from Jayendra. Is API server kind of a REST endpoint which can be executed from external application? And if I'm not wrong, API server could be first point of contact with master's process or Kubernetes server. Absolutely correct. In fact, that's what I'm saying, that API server is a kind of an endpoint that's going to talk to the rest of the thing. So to be more precise, I'll just explain you how this is happening. Let's say this is your master node. This is your master node, right? And this master node has various components. Okay, I just want you guys to be active. Please tell me what is the first component. If somebody can just turn on the mic and just tell me. पहला component कौन सा है? API server. ठीक है. Good. Next.
Cluster store.
Perfect. Cluster store. Thank you. That's great. Okay. Third one.
Controller manager.
Controller manager. Perfect. And fourth one.
Scheduler.
Scheduler. Perfect. So coming back to question of Jayendra, how this happens is, this is your master node. This is your control plane. This is your Kubernetes control plane. Right? So you have two ways to actually fire these commands. If you have worked on AWS or if you have worked on GCP, you might have seen that Google has Google Container Engine, and in case of AWS, you have COPS. So these are the things, those are the kind of the wrappers which come with the cloud platforms, which helps you to create kind of a Kubernetes cluster, right? So what basically happens is, if you have something known as kubectl, it's a kind of a command line, it's a kind of a CLI to this Kubernetes control plane. So if you just fire these commands, it's going to have a REST API call. It's going to have a REST API call to this API server. So API server is a kind of an external endpoint, which is going to control, or it is basically exposed. So let me just put it in this way. So it's going to make your REST API call over here. So if you just fire this Kubernetes command over here by using kubectl, it's going to talk to this particular KCP, and this KCP is going to fire a REST API call. Of course, if you want, you can straight away also fire any API call if you want, like this. So that is also equally fine. But in that case, you should know the specific API call to make so that you can execute whatever commands you want via an API server. So basically you have two options. You can do it via this kubectl command. In turn, it's going to call this particular master node via the API server through the REST API calls. Or else, if you want, like you can also fire your own particular HTTP client and call this REST API on this API server, and you can execute your jobs over here. Okay, I hope it makes sense. Okay, so we have this thing now. So we know what is meant by a master. Okay, let me just correct my terminology a bit. It's not master node, it's master, because I'll make a kind of a confusion if I don't be more specific over here. Right. So now let's try to understand what is meant by a node. Okay. So now we will see what is meant by a node. So in each of a particular Kubernetes cluster, you can have multiple nodes, right? And these are the nodes. These nodes either can be a virtual machine, or it can be a bare metal server, right? Or it can be a cloud node, or it can be an OpenStack node, right? So I think somebody is commenting in Meetup group. Shraddha, if you can just see if somebody has any questions over there. Yeah, Vinay Pat. Okay, I guess Vinay Patel is saying, if possible, please record. Yeah, we are doing a recording, and we will also paste this link of the recording in our Slack channel. That's what he's saying. Fine. So we have these nodes over here, and these nodes are the instances which is going to execute your workload. So let's go back to this Trello and try to understand what is meant by a node. So node basically has three different processes. First is something known as Cubelet. So what is Cubelet? This Cubelet is the main kind of a Kubernetes agent. It is responsible to register node with the cluster. It is going to watch the API server. It is going to instantiate the pods. Now, pods is something new for you. You might have not heard this terminology in Docker. And that's how pods is the thing, how it is completely different than a Docker swarm. So if you know the concept of this Docker swarm, the concept of pods is actually completely different. And so basically, this kubelet also reports back to the master in case the node is down, or maybe the pod is down, or whatever status update has to be done. It is actually happening through this kubelet, and this is generally exposed at port number 10255. It has like one more particular component known as container engine. Now that's the question which I suppose Manoj was also asking. So this container engine has a container runtime. This is where you are going to, pull the container and execute the container, right? So by default, it is Docker. But if you want to, use something like Rocket or something, you can do it. And I can see Rocket is making a good progress, as compared to Docker. People have started also using Rocket. And we will in future, in coming years, or in just coming months, we will also be able to see different other kind of the Docker container, different kinds of the containers also, which are going to be pluggable in this container engine. And the third one is kubeproxy. Now kubeproxy is the one which is going to connect to this KCP, and it is going to give you a kind of a Kubernetes network. So basically, once you have this multiple nodes and multiple pods, you will need a medium through which each of the pods and nodes will also talk to each other. So kubeproxy is something which is going to help you do that. In fact, if you also want to have a secure kind of a connection with your particular node or particular pod, you can use kubeproxy to do that. that's a bit of an advanced thing. We are not going to cover those things in this particular session. We'll just cover a few of the basic things in this session. So coming back to our diagram, now you guys have to just tell me what are the different components of a node. Yes.
Proxy.
Queue proxy. Good. I think that was Chetan, I suppose. Next.
Cubelet.
Sorry. Cubelet. Perfect. So Cubelet is the one which is responsible to talk to the master. मतलब इसको मैं थोड़ा ऊपर रखता हूँ क्योंकि ये master के साथ बात करता है. ठीक है? So this is Cubelet. And let me expose this over here so that you guys can try to understand this in a better way. Okay. Don't take this diagram in a kind of a literal way. It is just an explanation stuff. Okay, this is Cubelet, and there is one more thing, right? That is container engine, right? Perfect. So this is how. So this is a broad level, kind of an architecture of it. Okay, but there is one more thing. Inside these nodes, there can be one or more pods. And pods, I'll just come to it. What is meant by a pod? That's how it is completely different from Docker Swarm. In case of a Docker Swarm, this container was something which was a kind of a deployment unit. In case of this Kubernetes, pod is something which is going to be useful for you. Okay, so let's go back to the concepts. Pods, perfect. So in case of pods are these are the atomic units of scheduling in this Kubernetes. Okay, so pods means what? Once again, pods are atomic units of scheduling in the Kubernetes. So basically, if you try to see different systems, in case of the virtualization, VM image was a kind of a unit of deployment. In case of Docker, these containers were considered to be unit of deployment. And in case of this Kubernetes, so if you guys don't know, this Kubernetes is also known as K8s, K8s. To be short form of this Kubernetes. So eight characters between K and S. So it is a short form is K8s. So in case of this Kubernetes, unit of a kind of deployment is known as pods. Okay, and that's how it is going to schedule a job. So your question would be that in case of Docker, what used to happen was we had a Docker container and we used to deploy it in a node, and each node used to have a multiple container, right? So in case of pods, what's going to happen? Okay, I have a question. Manoj is asking, so it's like this container run? Okay, so let me explain you this. Let me explain you in the context of Docker, and then I'll come to the context of this thing. So let's go back in time. In time, if you had this virtual image, what you used to do is you used to simply deploy a virtual image over here. And this image had to have an entire, image of the operating system and the application, so on and so forth. Then we had something known as containers, right? But what used to happen in case of the containers, we had something known as Docker Swarm. So let's say you have nodes in case of a container. So let me say this is a node. Okay, this entire thing is a node. This entire boundary is a node. And you had a facility to deploy. So this node had something known as container runtime, right? So let's say this is your Docker daemon, which is your container runtime. and you can deploy multiple this containers over here as you may. So that can be container 1 or container 2 or container 3, so on and so forth, right? If you so it was your own will how you used to deploy it. So in this case, what is happening is container is a kind of a unit of deployment. Okay, this is how it used to happen in case of Docker. Okay, now let's switch to pod. So basically this is your node. This entire thing is your node. मतलब ये इसके ऊपर जा रहा हूं मैं. So in this Kubernetes, once again I'm repeating, you have master, you have nodes, you can have like this multiple nodes into your cluster, and it can be on a virtual machine or a bare metal or a cloud or whatever. And inside this node, once again you have something known as pods. So let's say this is node 1, and node 1 can have something known as pods. So let me say this is your pod 1. Round is not a good way to project it. Let's say this is your pod 1. So pod is a unit of deployment over here. This is your pod 2. Okay, and pod 3, whatever. Okay, each pod can have one or more containers. मतलब नोड के अंदर pods हैं, pods के अंदर फिर से container है. ठीक है, so this container which was there over here can come over here.
Parth, one quick question here.
Okay, tell me.
So the node process would be dedicated to a single machine, or a single machine could have multiple node processes?
Generally one node, one machine.
Okay. And master would be running on the different machine also, right?
Correct.
Okay.
Generally, when you speak about this concepts known as this, like we will see this, we have something known as MiniCube. And what basically MiniCube does is it uses the concept of this VM, and on a single machine you can have a master and a node together. So if you want to keep it on a separate, if you want to keep masters and nodes on a single machine, obviously you will have to use the concept of this this particular virtualization and then do it. So basically one execution place is going to be master, and the rest of the execution place is going to be nodes. It is up to you how you are going to define it. But in case of the general terms, one machine or one VM or one cloud instance equals to master, and one machine, one VM, and one instance is going to be node, right? Okay. Manoj is asking, in Docker, one node, one container. No. In case of Docker, if you see over here, this itself was a node. If I'm not sure whether you had attended our last sessions in Docker Swarm or not, but in case of Docker Swarm, you can execute like multiple instances of the containers into a single node. So into a single node, you have multiple instances of containers. Okay. In case of so let's say pod 1, pod 2, and pod 3. Okay, and in case of pod 1, like you can have multiple containers. Now generally, though I am saying that you can keep multiple containers, it is not a good practice to have multiple kind of a containers over here. What kind of a containers you can put over here is, let's say if you have a kind of a front-end application into one container, and it has a kind of a back-end API, or maybe if you have a DB, or it has a kind of a Redis, which is going to be useful for you, right? So those kind of components you can put it, but it should not be like this, that front-end 1 and front-end 2, right? It is not the kind of an application unit, right? So basically, best practice over here. So though pod can have multiple containers, it is not a unit for a kind of a replication. What you can do is you can have a kind of a related containers over here. Okay, most of you, if you might have attended the earlier sessions, we discussed about this Docker Compose. And in this Docker Compose, what we used to do is we used to turn on the whole stack from the front end to the back end into a single kind of a Docker file or a kind of a Compose file. And then that stack. So basically, when we speak about this, a pod can have multiple containers of a stack, but not a kind of a replication unit. Still there are questions. Manoj is asking, so we have to make one image and run on one container of multiple images to one. I'm not sure, Manoj, what you mean by that, but I'll just come to that question in a bite. Paresh is saying, so we can one pod, one container, right? Yes, we can have one pod, one container. That's fine. It's not rule. It's not compulsory to have multiple containers in a pod. Pods are basically for a single kind of a pod is a kind of a it's a kind of a place where you will put your containers. Okay, it's a place where it's going to execute one stack. Okay, it's not compulsory to have multiple kind of containers, and in most of the cases you are not going to have multiple containers in a single pod unless and until it's like this, where you have front end and kind of a back end into different kind of different kind of the containers. So if you have a kind of a related container, you can put it, otherwise you will not put it. Okay, Ravi is asking, so basically, can you all ask the questions one by one, starting from Parth? I guess Parth is asking a question, what is the benefit of pod, because we can achieve same thing in Docker. Okay, I'll just come to this question, Parth, after a bit. Your question is okay. And Ravi is saying, can we set up master and pod in one machine? Yes, of course you can set up. I'll just explain you that in a bit. Paresh Chauhan is asking, I think we get good performance. Okay. Kiran is saying one container E2E flow of application or its single module. I'm still not actually getting that question. If we can come back to Parth. Parth has asked me this question. I'm not sure who this is. What is the benefit of pod? I'll just come back to you in a short while, right? Other question was, so we can one pod, one container. That's we have discussed. Okay, fine. I'll just come back to most of the questions in a while. Okay. Now, if you guys want to ask the question, please just turn on the mic. Ask me. Okay.
So the best way to scale the application in Kubernetes is at master and pod level. Sorry, node and pod level.
Correct. So pod is the kind of a basic, kind of a thing to scale up. So instead of node level, I would say it is at basically this pod level. Pod is a place which is going to execute your particular container, in contrast to what used to happen in case of Docker. Okay. Yes, Kiran, please tell me. So it depends on your architecture of your application. So what you can do is like what most of the people do is they have a front end and a back end deployed into one kind of a container, but that is not going to give you a kind of a scale up. What basically you can do is you can have a different stack and into different kind of the containers. Let's say you have a front end into one container, you have a back end into one container, and you have this database or a kind of a Redis into one container, and then you can scale it up as you want. So it actually depends on the architecture of your application, what part of the application you want to scale up. So for the places where you need basically you need a kind of a scalability, those things you will put it into pods, if you want. And where you don't need a kind of where you don't need a kind of a scalability, you can execute as a single kind of a container. Correct. So we have something known as you have something known as Kubernetes control plane, and this Kubernetes control plane is basically something which is it also acts as a kind of a virtual kind of a network between all the master nodes and the nodes. And you have something known as this kube proxy over here, which is actually responsible to maintain a kind of a network over here. What happens is this kubelet also gives you a facility to bind yourself to this DNS. So basically what happens is your each and every kind of a Kubernetes cluster is given a kind of a DNS access. Each of the pods are going to assign a kind of a IP address and a kind of a DNS to it. So if you want different pods to actually talk to them, of course you can do that. We'll start with the basics first, and then in the couple of particular sessions we'll also see how each of the pods can actually talk with each other. But yes, it like if you want, each of the pods can also talk to each other. Have to do it by using this control plane and a kind of a virtual network which is there in this Kubernetes control plane. Okay. That's so. So that is so that's how basically the pod is. So coming back to the concept of pod, what is pod? Pod is a ring fence environment to run a container. Okay, and it has basically these many things. Each of the pod, so all the containers in the pod are going to share the kind of the network stack and the kernel namespace, and there can be n number of the containers, but I said that they should be linked to each other. Okay, so that's it. So basically pods are something known as atomic. So when you try to deploy a pod, it either deploys completely or it is not going to deploy. So let's say if a pod has 2 containers, it's not that one of the container will be up and the second will not be, right? It's going to be a kind of a complete process. We'll also see this when we see an example. And basically a pod has 3 different states. One is a pending state, second is a running state, and third is a succeeding state. We'll see to this afterwards. The main thing about pod is once it dies, it is never going to turn up again. Okay. So what happens is in case of the containers, you can stop the container, you can start again. In case of pods, either it dies. If it dies, you can't restart the pod. It's going to be a new pod, and that how to restart the pod, it's going to be taken care by the particular controller. So you don't have to actually actually worry about it whether your state is going to be maintained or not. Now to use this particular Kubernetes, we have various ways to do it. Either you can use this MiniCube. So basically MiniCube uses the concept of this virtualization to have master and the node in the single machine. So I have installed this MiniCube into my machine. So I'll just open my terminal. So what you guys can do is you can just try to go to the installation of this MiniCube into place, MiniCube. So based on your platform which you are using, either you're using Linux or Mac OS or Windows, you have various steps which you have to execute to install MiniCube. Okay, I have this MiniCube installed into my machine. Okay, and to see whether it is installed or not, very simply you say MiniCube and then version. Okay, so this is the version of this MiniCube. And I can also see whether I have this Kubernetes installed on my machine or not. So there are various ways to install this Kubernetes, like various kind of, you have this various flavors. You also have an installation of a Kubernetes which comes into this Docker. So if you install a Docker, they have a version of this Kubernetes installed. Or if you want, you can also install this Kubernetes into your machine in your way. First thing which you will have to install is something known as kubectl. Kubectl is something, it is a process, it's a kind of a CLI which is going to talk to your Kubernetes control plane, and that's how it is going to be helpful to you to call and to send the particular manifest files to your master nodes, and then have different kind of the loads distributed to the cluster. Is this better? Okay, thanks. So I'm not, looking into the chat section much. So if you have any questions, or if you want to tell me something, please just turn on the mic and please just say it to me. Okay. Correct. It's going to give only one master and one node. It is just for the purpose of testing, just to actually, have a feel that you are using this Kubernetes. We will also see in this particular session, we will also deploy it into multiple clusters. We will use something known as play with Kubernetes, and that's also what we did in case of Docker last time, and we will do it today in case of this Kubernetes as well. So we'll deploy also this on a multiple nodes in cloud also. Let's start with this MiniCube first, and then we will jump to it. So first of all, whether you have this kubectl installed into your machine or not, what you do is you say kubectl and minus version. I think it should be kubectl version. Yeah, so it's going to give you the client version as well as the server version. Also, if you want to see what is the context in which your kubectl is connected to, very simply what you can do is you can say kubectl config, and you can say context. Okay, kubectl config has some options. Get context, current context. Okay. So you have different context in which you can execute it. So let's say this is current context. So it is saying that you are executing this in MiniCube, and you can also say get contexts. So like I said, it also comes with Docker desktop. So I also use this with Docker desktop version, and I'm also going to use it right now with this MiniCube. So it's up to your choice which one you want to use. On this particular machine, on a kind of a local machine, it's just going to be a kind of a simulation. It's not a kind of a real thing, because you have just one master and one node. So it's not going to be a kind of a replication of sorts, but I mean, basically, if you want to try it out on your machine, you will be able to do it. Okay. So if you are working on this multiple machines, you will have to install something known as kubeadmin. So kubeadmin is the thing which is going to make one master node out of multiple nodes, and then you will also make the different nodes and try to connect all those nodes into your particular parent or master node, right? So that's going to happen by using this kubeadmin. Kubeadmin is the particular commands of kubeadmin are going to be something similar to your Docker Swarm. So if you guys have attended a few of the previous sessions, you will get the idea what it is happening over here with case of kubeadmin. I'll come to it in a bit. First, let's see a few of the basic commands. So kubectl version, as you know, it tells you the version of your kubectl. This is going to tell you the context. Next is kubectl get nodes. So in this machine, you guys know that we have just one node, right? So very simply, if I say kubectl get nodes, it is just one node, that is this MiniCube node which I have done over here. We'll see it in a short while how we can see multiple nodes. when we try to deploy it to cloud. Okay. Next is this is a way in which like you can fetch pods. So kubectl get pods is good. This is the way in which you can see different pods. So I was actually practicing last night, and that's how I have these many pods over here. And if you want to delete something, very simply you have an option of this kubectl delete. Either you can just delete a node or a pod or a service, or things like that. So this is how these are one of the a few of the basic kind of the commands to use. Let's get started now. Let's deploy an application into this Kubernetes and try to see what is happening. So if you guys,
Parth, one question. kubectl is a part of the Kubernetes installation itself, right? Or because I downloaded the kubectl application, I tried to execute the command, but there are some configuration needs to be set there.
Yeah. So kubectl, in which platform you are trying to install?
Windows.
So you have to install kubectl process. It should be there in the installation. If you are not able to execute it, it means you have missed or not done the installation in a proper way. I have not tried kubectl in Windows, but as far as Mac is concerned, as well as Linux is concerned, it's very simple. You have this sudo apt get update and you install this kubectl. In case of Linux, in case of Mac, you have brew install. So try to just follow the steps of this Kubernetes installation in Windows properly. I'm sure you might have missed some of the part.
Okay.
Okay. So let's get started with this. So what we will do is we will start with our application, which we did last time in case of Docker. So for those who were there in the last session in Docker Swarm, you might know we had done something like this. We had this Flask app, which I made. And we had replicated this Flask app into different instances in the cluster. All right, and that's the process. That's the application which we had deployed last time, which basically used to send this response in kind of a JSON format. And for each of the node in the cluster, you have different server names. So that's how we used to, get that's how we used to get that this response is coming from which particular instance or which particular kind of a container or a server. So we have this application. We will have this application deployed at port number 8000. Okay. So that's what we are going to basically deploy to this Kubernetes. So I have this Docker file, and I have also deployed this container or this particular image to my Docker hub. So we'll use that particular image for the deployment case. Okay. So coming back to my console. Let us deploy a single node. So I have made a kind of this particular manifest file for this. Okay. So what you can see over here is it's a simple kind of a YAML file. So this is something similar to the Docker file which we see in which we had seen in last sessions. Like we had seen a Docker file, we had seen a Docker compose file, right? So this is something similar to that. It has a bit of a different kind of syntax, but it's basically a same thing. This has API version v1. So basically that is the version of this Kubernetes kind of the syntax of this particular manifest file, which we are going to see. The kind of this particular thing is pod. So we are going to deploy a pod right now. Inside this metadata, we'll give the name of the pod. The name of the pod is my Flask app. Inside it, we have this containers. So what is the container which we are going to deploy in this pod, right? The name of the container is Joshi Parth in my Flask app. So this is going to, since Docker is the default container kind of runtime over here, it's going to take Docker Hub. So it's going to poll to the Docker Hub and it's going to fetch my particular image over here, right? And the name of this container is going to be my Flask app CTR. And it is going to be deployed and it is going to be exposed on port number 8080. Let me change it to 8000 because my my particular container is going to be deployed on 8000, right? So this is what is the pod about. So if you want to start this pod, very simple, what you will do is you will go to this command prompt. You have this file over here. You will say kubectl and then create is going to create this pod -f. By -f you're going to say you are going to give a kind of a manifest file to your master, and then you are saying pod.yml. So this is going to give this particular manifest file to your master. Your master is going to parse this particular YML file and is going to take the description of the pod which is given in the YML file and is going to deploy this pod into the node, right? So it is saying pod my Flask app is created. How do we know whether it is created or not? Very simply, you will say get kubectl get and then pods. So it is saying you have my Flask app which is executed and it has age is 15 seconds. It is running, right? Now let me see what are the states inside it. So to do that, what I'll do is I'll say describe and then the name of the pod, describe pod my Flask app. So if I see if I say describe, it's going to tell you all the details about this pod. So it is having an IP address. So each pod is going to have an IP address. That's very obvious, because if you want pods to speak to the other pod, right? Each pod should have an IP address which it is going to use to actually communicate. And we have the status of the pod, and these are the events. So if you see very carefully, what happened in this case was, first it started with, it was scheduled, then it tried to pull the container from Joshi Parthin / Flask, my Flask app, and then it had actually created the container, and after it the state became to started, right? So these are the different states of this pod which you can see over here, right? So these are the things. If you want to see the details of the things inside this particular pod, it's possible to see from here. Okay, now kubectl get node get pods -o wide. So if you do this, it's going to give you more details. So if you can see over here, this node. So in my machine, I have just one master and one node. And inside this node, I have 3 different IP addresses. It means I have 3 different pods over here. 172.17.0.6.7 and .16. So this is the one which we have just executed right now, right? So this is how.
I have one question. You have created one file for this pod, right? So that file automatically created and all that manifesting things will be done by Kubernetes, or we need to do some coding and all things?
I did not get your question properly.
As there is a pod.yml file, right?
Yes, correct.
So is it created automatically, or we need to write?
No, this file is made by me. I have actually made this file just to actually save time. I am just actually showing you this file. This is a kind of a file which you have to make, something similar to the Docker file. If you are actually familiar with Docker, we have something known as Docker file and this Docker compose file, right? So this is something similar to Docker compose file. And you have this kind of a YML file which you have to create. So this is a description. This is a description which you will give to your master. Okay. So what basically happens in case of Kubernetes is, this is your particular Kubernetes, right? In my machine, what is happening is, let's say this is my machine, and in my machine, I have just one node. Okay, so try to just consider that I have just one node. I don't have multiple nodes in my machine. Okay, so what happened was, you have this manifest file, right? You have this manifest file. Manifest file in your case is pod.yml. Okay,
Yep.
So through this particular kubectl, you are giving this manifest file to this API server. Okay.
Okay.
You're giving this manifest file to this API server. This API server is going to process this manifest file based on the description which is mentioned in my manifest file. It is going to deploy pods to this node. So in this particular node, if I just click this node, I'm just going to zoom it over here. It has 3 pods as of now. Okay, this node has got 3 pods, and pod 3, which I just deployed right now, is having the container of my Flask app container. Okay.
Okay.
So
actually, you write that command, and in that command you didn't mention any YML file and that reference.
no, I had mentioned. You see, I said kubectl create
okay.
-f and then pod YML. So after this particular command, it had started this pod.
Okay. Yeah, got it. I thought that
Got it.
that is only file name and it will create automatically.
No. You have to execute this command. So once you execute this command, it is going to give this YML file to your master, and master is going to process this file, and then it's going to distribute that particular pod for you.
Okay. Thank you. Yeah.
Okay. Sorry. Kiran. This is the old application. This is old application. This is the one which I have deployed. Okay. Okay. So like from this thing, I think you will be able to get. So this was actually deployed before 2 minutes. This was deployed by me last night while I was practicing, and this was in the morning while I was practicing. Right. So this is the one which I have just deployed before 2 minutes. My Flask app. Okay. Now the point is, we have just deployed one container into one pod into one node, right? That is not true format of this clustering and not true strength of this Kubernetes, right? So first what we will do is, first we will see how to create a cluster inside a single node, and then we will repeat the same process into a kind of a cluster into multiple nodes. Okay, so let's see how you can just create a cluster. So to do that, what I will do is, I'll go to my folder cluster example. So once again, I have made a file over here for you. So why this is showing me this file? Okay, yeah. So in this folder, I have 2 files. in this one file, I'm going to create a cluster, and in second file, I'm going to create a service. I'm going to repeat. In first file, I'm going to create a cluster, and in a second file, I'm going to create a service. To explain, your first question would be, okay, Parth, what is this particular thing as service, right? So coming back to the concepts of Docker. In case of Docker Swarm, what we do generally is we have nodes, we deploy applications in cluster into nodes. We have something known as a kind of a UCP, which we call it as Universal Control Plane in case of Docker, UCP, and which has something known as ingress network. I hope you will be able to recall this from the last session, which has something known as mesh network. So what happens is, if you try to ping to a particular node over here in this example, okay, if you try to ping to a particular IP address, your mesh network is going to find out based on the default load balancing, which is the application to which it should send a request, and it is going to send a request in a kind of a round robin fashion. So what we did in case of Docker Swarm is we had deployed this application as a service, right? And we used to access this application in a cluster in form of a service. And it was this particular UCP or the ingress network which used to do the load balancing for you. Of course, we had seen that you can also configure a third-party load balancer like this HA proxy or Apache to do your job. That's obviously you can do, but that's a basic way in which your clustering and your load balancing was happening in case of Docker Swarm by using Docker service. Okay, now coming back to our concept of this Kubernetes. In this Kubernetes, you have pods. Okay, let's say you have pod 1, pod 2, pod 3. Doesn't matter in which node. This pods can be in a single node or it can be in a multiple node. Okay. Now, as per the concept of this Kubernetes, it is not a kind of a reliable thing, and also Kubernetes does not let you do so to straight away contact a pod from the network. It is so. This is your client, let's say. And if you want to straight away access this particular pod, Kubernetes will not let you do so. Though you can do it, but it's not a good practice altogether. Okay. Instead, what basically Kubernetes is saying, because why it is not trying to let you do so, if you are trying to hit this pod and let's say tomorrow this pod dies, okay, due to some reason, this is a kind of a broken thing, right? This is a kind of a broken thing. This breaks. So to not let this happen, a kind of the architecture which is given by this Kubernetes is that you have something known as a service in between. So you don't have to worry that inside in the background, whether you have one pod, 2 pod or 3 pods, right? You just have to talk to this particular service. Your client is going to speak to this service, and service is going to in turn speak to your pods. That's how it's going to maintain your HA, that is your high kind of availability. And it's also your client will be, not completely depend on the fact that how many IP addresses or how many pods are there in the background which are executing, right? You simply have to call this particular service, and this particular service is going to call your particular pods in turn. Okay. So for that reason, you have to deploy two things. You have to deploy your cluster. This is your cluster of your pods, right? And you have to deploy your service. It doesn't actually matter that whether your clusters are, your pods are deployed into a single node or into a multiple nodes. It may be possible that pod 1 and pod 2 are running into, let's say, node 1, right? And this pod 3 and 4 are executing in node number 2 and node number 3. It's quite actually possible, but all these pods together form a cluster, right? So what basically you have to do is you have to deploy this cluster and you have to deploy a service, and then we will try to access our application through this service. Okay, so that's what we are going to do in this session. So let's come back to our IDE. So this is your IDE. Inside this, I am making one file that is rc.yml. This YML is a manifest for my cluster, and this is svc.yml, and this YML is for my service. Okay. So cluster, in this cluster, most of the syntax is something similar to what we saw in case of pods. You are mentioning the API version v1, which is of this Kubernetes kubectl. What we are going to deploy is a kind of replication controller. So basically, replication controller is a wrapper which sits on top of this pod, and this is a kind of a controller which takes care about your particular cluster. So it's going to make a kind of replicas, 10 different replicas of this particular container, right? So there will be 10 different pods which are going to have, and each of this pod is going to have this particular container, right? So that's how it's going to be deployed. And then you have something known as this service. This particular service, the name of the service is going to be my Flask app SVC. Now, one thing you might notice that how will the service know that it's going to talk to this particular pod or these many pods from the cluster, right? So one smart thing which is there in case of Kubernetes is labels. Your service is going to connect to your pods by these labels. So what is happening in this is that each of your pods is having a label which is known as app, and the value is my Flask app. So this is a key pair value. This app, my Flask app, is a label which I have made for my particular deployment, and this particular service is going to connect to that label. So if I show this in this particular diagram, it would be, let's say, my pod 1 has got label 1. Okay. Pod 2 also has label 1. Pod 3 has label 2, and pod 4 has label 1. Okay. And my service is trying to select, which particular label. It is trying to select label 1. So now I want you guys to tell me this particular service is going to connect to which pods?
Of the 3 pods.
Sorry?
Any of the 3 pods except pod 3.
Correct. Absolutely correct. It's going to connect to pod 1, pod 2, and pod 4, but not pod 3. Why? Because it is having a different label, right? So instead of lab 1, lab 2, lab 3, what I have over here is I have the label as my Flask app equals to my Flask app. So this is the label which I have created. Okay. So this is your cluster and this is your service. Okay. So now let me jump into my terminal, and let us start this particular cluster and also the service, and let's try to also access the application. Okay. So to start the cluster, what you will do is you will say kubectl create -f, and then the name of the file is rc.yaml. Okay, so it has started the cluster. Let me see how many pods it has started. So it has started kubectl get pods. So you can see it has started 10 different containers. It is saying container creating, right? So it is still doing something. So let me just inspect this particular pod and see what is the status. So it is kubectl get describe and then the name of the pod. Describe what? So you have to say describe pod and then the name of the pod. So now it is started, right? So now if I go back and if I say get pods, I'll be able to see all my pods which are started. Okay. So this now I do have my cluster. So over here I have 10 different pods of my application. Instead of 4, I have 10 different pods, right? Which has a cluster of my Flask application. The thing is, it is deployed into like a single node right now. Okay, we'll just get back to that, and we'll also try to deploy into multiple nodes. Now I will deploy a service. So I'll say kubectl create -f svc.yaml file. So it has started a service. How to see whether it has started a service or not? So I'll say kubectl and then get services. So this is the service which has started. It has started 15 seconds before. Now these IP addresses which you are able to see over here, these are all virtual IPs. So what happens is inside this Kubernetes, your service and your pods, each of them are going to have their own virtual IP addresses. So this 10 dot something which it is showing over here are those virtual IP addresses. Okay. Now what we can see over here is the application is deployed at port number 8000. So in each of the pods, it is going to reach out to port number 8000. But my node ports, right? The particular service port is at 3001. Okay. So basically this particular service is going to talk to 30,001, not 3001. Okay. So coming back to my services, what would I do if I want to access this service? So it is MiniCube service and then the name of my service, this one. Okay, so this is my service. So now if you see over here, this is my application which is running. This is actually executing on port number 3001. So it is trying to reach to 3001. This service in turn is trying to reach out to these pods at port number 8000. Right? So this is how it's executing. Right? Now to see
how we can
whether it is
how we can come to know from which port that request is being out.
Absolutely, I was expecting this question. So if you just remember in last session of Swarm, we had kept this particular server name, right? Each pod is going to have a kind of a unique server name. So that was a code which I had actually written in my Flask application, that each of this server is going to have a different and a kind of a unique server name. So let me refresh. So each time if you observe, you will see a different server name. So basically, if you try to observe carefully and do it, 10 times, it's going to have 10 different server names, right? So it's a kind of a round robin fashion in which it's going to reach to different pods. Okay. So that's how it's once, when you say once it's going to reach to this, then it's going to go to this, then it's going to go to this, then it's going to go to this. So if you want to do a kind of a load, a kind of a testing like we did it in the last session, very simply you can say minus n1000 and minus C4 and then your local host IP address, which is this one. And if you paste it, what did I do wrong? Okay, slash, I forgot slash. So you can see last time, like we were on 120 requests per second, or around about 200 requests per second. Right now we are on 419 requests per second. So that is much of a kind of a scalability which we have right now with this cluster, right? So, but the point is, we have deployed this cluster, but pods are deployed on a single node. That's not a flavor of this Kubernetes which we would like to see, right? So instead, let's deep dive into this play with Kubernetes. So what you can do is either you can have this 2 or more AWS nodes, and then you can do it, which I believe we will do it in the upcoming sessions. For just to get started with, we will go into play with Kubernetes, and let's add in nodes over here. So this is one machine. This is machine number 1. This is machine number 2. This is machine number 3. So let's start with 3 nodes. This machine number 1, I will make this as a master node. So what we have discussed earlier in the Trello board is that if you want to actually manually install, you have something known as kubeadmin. So what basically you do is first you initiate the kube. So this is a command which you use to do it. And then you have to actually set up a kind of a network for it. So generally you use known as Weave. Weave is a name of a network which you will use for this Kubernetes. And then you can, so once you do this kubeadmin init, that node itself will be acting as a master node. And after that, you can have a kind of a token join for each of the nodes in the cluster. Something similar to what we used to do in case of Docker Swarm. So coming to this, it also gives you a hint of this particular command. So I'm going to do docker admin init, sorry, a kubeadmin init over here. So I'm simply going to copy this command. I'm going to paste it over here. So this starts your Kubernetes cluster. And this is going to make this node as a master node. We'll just wait for a few seconds until it gets booted up. It takes few of a second to get started, but after that it's smooth. Once we will do, once we are actually done with this, we will also create our own Kubernetes network. That is a cluster network. Fine. So we are done with this. One thing you can observe is something known as kube proxy. So kube proxy is a component, if you can recall, in case of master, in all the nodes, which takes care of your networking. Okay. Next is, let's start our network. So we will actually configure a Weave network. So this is a virtual network with which each of your Kubernetes nodes will be speaking to each other. So this is done. Once this is done, you simply have to use this kubeadmin join command, and you will just pass a token inside it, with which you can have rest of the nodes connect to this master. Now this is something similar to the Docker Swarm thing, which you can recall. We used to do this. And similarly over here, I'm going to, in the node 3, I'm going to connect this. So what is happening over here, this node 2 and node 1 are now part of the cluster with this master node. Okay. Let's see get. So basically we will go to this node 1 and we'll fire kubectl get nodes. I don't know what it is taking long, but let us wait. Yeah. So like we can see, we have two nodes, node 1 and node 2. And node 1 is the master node, and node 2 and 3 are your simple nodes, right? And this is much better in contrast to what we had seen in our local host in case of MiniCube, where we have just one node, right? Now let's make a cluster over here, and let's also start the service and also access our application over here. So very simply, I'll go vi and I'll say rc.yml file I'll make over here. Insert, I'll copy and paste my rc.yaml file. Okay, this is my rc.yaml file. I'll come out of it. And also I'll create my service file. So I'll say svc.service.yaml. Insert, svc, copy, paste. Fine. So now this node has an instance, so has both the files, that is rc.yaml and service.yaml. First, I will start my cluster. So to do that, I'll say kubectl create -f rc.yaml. So by doing this, it's going to start my cluster. If I say kubectl get nodes, get pods, sorry, not nodes. So over here, you can observe that few of them have started, few of them are still starting. And if I do it after a few seconds, I should also be able to see it. Yeah, so I have all the nodes, all the pods which are running. Let's also see how these pods are distributed across different nodes. So what we'll do is kubectl get -o wide, get what? I'll get pods, right? So get pods -o wide, it's going to show more details. So one thing which you can observe over here is all the nodes are distributed between node 2 and node 3. So we have 3 nodes, but in case of Kubernetes, what happens is master nodes are not going to take any job for you. It is just going to do the orchestration. Workload is going to be taken just by nodes, as we have discussed in the beginning of the session. So all the load is distributed between node 2 and node 3, and these are the IP addresses of these pods. Basically, these are IP addresses of yes, these are IP addresses. And if you might see very carefully, this node, that is node 1, is not actually taken into picture because that's a master node. Okay. So now coming back to our service, let me now deploy the service. So I'll say kubectl create -f svc.yml. So it is saying that my service is deployed. I'll say kubectl describe, or let us simply say get services. So you can see over here that service is deployed at port number 30,001 for the service, and 8000 is the port of my pods. So if I want to access this, what I'll do is I'll simply copy this kind of a public facing, kind of a URL, and I'll just go over here in my browser. I'll say port number is 30,001 because that's where my service is exposed, and I'll execute it. So once again, you will be able to see the service executing over here, and you will be able to see 10 different server names over here. And how it is happening? It is happening via distributing the load across all the 10 pods over here, right? So I have this container which is deployed on this 10 pods, and these 10 pods are distributed across my cluster of 2 nodes. And these 2 nodes are being contacted by my service, and this service is going to do load balancing for me. It's going to take care about how to reach out to this pod and execute that particular service and give you the response back, right? So that's how we deploy a service, right? If we go back to my Trello cards, this is about Cube admin, which we were discussing. We saw about the Trello, a single pod which we had, deployed. And this is about distributing making a cluster of service. And that's how we can, deploy a service into a Kubernetes. We can also deploy a deployment. The basic that we will see in the next session, the basic power of this deployment is that you can have roll-ups and roll downs. So what is meant by this roll-ups? That you can update your application seamlessly, and you can also downgrade your applications seamlessly. Right? That's the power of both of the things. So you will basically deploy a deployment in the same way as you did in a service. There's a slight kind of a different in case of syntax of the YAML file, which we will be seeing in the next session, right? So this is a basic of this Kubernetes. Next thing you might want to try it is, instead of making this clusters into this Docker playground, you can try it out into a Google container engine, or you can try it out using this AWS by using COTS. Now, like in case of the AWS, you have various ways to use this Kubernetes. One of the ways COTS, but you have various ways to use Kubernetes in case of AWS. So if you have an AWS account, you can just tweak a bit, or in the next coming sessions, we'll also try to have a session on it, how you can use this to like how you can use the Kubernetes by using AWS, and how you can try to deploy an application in that. Okay, hope it makes sense. Hope this session might have been a bit kind of helpful to you to understand and get started with the key concepts of this Kubernetes. So now if you guys have any questions, more things which you want to discuss and share, we can have that. Yes. Okay, good question. So one thing which I want to tell you, that it is also possible to describe a service and a replica set into a single file, right? It is possible to do that. Just for the sake of simplicity, I have split it into 2 files. I'll first explain you the cluster first. So rather than a replica set, it is a replication controller. You will use a replica set when you use the when you are going to use a kind of a deployment. Okay, this is not a deployment. This is a replication controller. Okay, so in case of a replication controller, what you are trying to say is that you have a Docker container, my Flask app. Sorry, you have a Docker image, my Flask app, and you want to replicate 10 different pods with a container image whose name is Joshi Parth in my Flask app. Okay, so coming back to the diagram, you want to deploy 10 different pods over here. Okay, instead of 4, you want to deploy 10 different pods. Okay, and this pods is going to basically form a cluster. Okay, so let's say you have few of the pods deployed into node 1, node 2 in our case, and few of the pods deployed into node 3. Okay, and this whole thing is basically maintained by a cluster, which in our case is replication controller. Okay, so basically this particular replication controller is a wrapper for these pods. Okay, which is going to have a kind of replicas of these pods. Okay, so what I'm mentioning over here in my service file, sorry, in my rc.yml file, is that I'm going to have 10 pods over here. 10 pods, 10 replicas. 10 means 10 pods of this particular Docker image. Okay, so that particular definition comes in my rc.yml file. Service is this particular component over here. So I have actually deployed a service. The name of the service is my Flask app SVC. Okay, just a second, I'll just put things at place. Okay, and it is actually it does have a label. So this particular service was going to find out all the pods with this particular labels. Okay, and it is going to try to access that particular pods at port number 8000. Okay, and this particular service is exposed to the external world at port number 30001. Okay, so how will this particular thing know that which particular pods it has to reach to? It is done by this particular selector. So this is a place where I'm mentioning that you have to reach out to all the pods with the label having app equals to my Flask app, right? So what it is going to do is it is going to find out pods. In this case, I have 10 pods with my label my Flask app, right? So it's going to call all those pods which has those labels, and it is going to call that particular service at port number 8000, right? So that is the difference between the description of these two files. If you want, you can combine this thing into like one file. It is also fine for you. I just wanted to make two different kind of the context for it. So that is the reason why I made two files out of it. Okay, I hope it makes sense to you. Kiran, it is. Service is going to identify the pods with labels.
Parth, I have one question here. Can we increase the replicas to update the rc.yml file?
Good question. So you do over here 20 and go back to your terminal. I'll do it on my this thing Excel local itself.
Yeah. No.
And kubectl apply -f rc.yaml create -f apply something is wrong. Kubectl apply should be used on resource created by either kubectl. So yeah, I did it by this. Acha, what happened was I used create and then I can't use apply. So that is the reason why it must not be doing it. Let me try it again. Kubectl get pods. Yeah. So now you can see 20 of them, right? Hello.
Yeah.
I hope this answers your question, Kamal, right? So earlier it was 10, right? Now it is 20.
Yeah.
So that's how
old pod will be delete and new pod will be created, right?
No. It is going to be scaled up. So if you see, baki na bada jaise, IP, I don't remember which pods were there. Let me scroll up. If I
It
can
will
find
add only 10 more.
8WCNC, wait, find it out. 8WCNC is there, right? So it is going to add more
Okay.
10 pods.
Okay.
See, what is the meaning of like the basic meaning of this this particular scaling up and scaling down is that existing should be there, right? You have to add more pods.
Okay.
Okay. Is there any other question?
Yeah, Parth, I have one question over here.
Yes,
If
Bhavesh.
I have one application and which has backend part differential and front end part, and there is some engine. So I have 3 instances of that application. So how can we manage over here?
Okay, so what you can do is what part of your application you want to scale up?
Like all, I think backend will be more scale up.
Right. So what you can do is you can use your front end as a kind of a separate service, and uh, like you can have the container as a cluster, right? And you just deploy this particular this backend as a kind of a container to this cluster, and you actually deploy this front end as a separate service. I mean. I think that should actually do a job for you. So if you want to do, I mean, if you want to have that particular thing also, we can also do it in the next session where I can just demonstrate how you can deploy a front end and a back end into kind of a Kubernetes cluster.
Okay, so we can't manage in one single node, right?
Yes, you can also do that. If you want, you can also have both of the things deployed into a single container. But generally, what happens is you have 3 aspects. One is front end, second is back end, and third is the database, right? So it would be difficult to replicate a database. But what you generally do is you deploy the application stack, and then you have a single copy of the database, or you have a replication set of your DB, right? So if you want, like, you can deploy front end separately, back end separately, and the database separately. So that's option number A. Option number B is you deploy your front end and back end as a separate stack in one particular container, and you can deploy your database as a separate service. So yeah, so like we have various types of the combinations you can use. So it's up to you which one you want to choose for your particular application and what is the architecture of your service.
Okay. Yeah.
But if you want, we can have some kind of a demo like this in the upcoming sessions.
Yeah, sure.
Okay.
Okay. Thank you.
Okay. Is there any other question? आपका वॉइस नहीं आ रहा किरण. हाँ जी बोलिए. हाँ. So yeah, so you have various APIs which you can call of this this particular master node. I think we are short of time as of now, but if you want, we can have this thing actually covered up in next session. Of course, you can automate this. You are absolutely right, and that's the basic kind of like the kind of magic of this Kubernetes. And also, having said that, it also depends on which cloud or which platform you are also actually trying to deploy. So if you're deploying in this AWS, so AWS has got various kind of the facilities and various kind of the configurations which you can do over there, which will also actually help you to scale up, scale down in a kind of an automatic fashion. So yes, we have ways in which we can automatically scale up and scale down, and like that actually is going to require a kind of a separate kind of a session for it. So what we'll do is we have few of the things, like one thing, the question which has come up with regards to the front end and the back end stack. So we'll also have a session for that, and we will also have a session for the one which you said about the automatic scaling. So we will also see that in the next session. यही होता है. So Kubernetes, see AWS, you cannot say उसमें भी जो बोलते यही काम होता है. See, we are scaling up from the application level. अभी हम जो scale up कर रहे हैं ना, वो application को scale up कर रहे हैं. AWS क्या करता है, उसके पास दूसरा भी बहुत सारा ऑप्शन है जो पूरे इंफ्रास्ट्रक्चर को स्केल अप करता है. मतलब अगर तुमको एक मशीन छोड़ा दूसरा मशीन चाहिए तो वो आपको स्केल अप करके देगा. हम तो अभी पॉड के लेवल पे स्केल अप कर रहे हैं ना. व्हाट वी आर डूइंग इज कि हम लोग के पास नोड्स हैं और हमने पॉड को स्केल कर दिया. ठीक है, वो क्या करता है AWS, तो आपकी यूजेज के हिसाब से वो तो आपका ये जो क्या बोलते मशीन्स हैं, उसकी जो सर्विसेज हैं, उसके जो क्या बोलते हैं जो पर्टिकुलर इंफ्रास्ट्रक्चर यूज कर रहे हैं उसको स्केल अप करता है. मतलब बोथ थिंग्स आर कंप्लीटली डिफरेंट. But this Kubernetes, since it's an open source project, every cloud kind of a provider has a kind of a connector for it. It has a kind of a dashboard for it. So basically, you can just try to configure various rules into your particular cloud thing, and you can try to scale up based on it. So kubectl is a kind of a command line tool for the basically kind of a deployment. But obviously, for the scaling up, you have got various options which you can pick it up. Okay. So is there any other questions which you guys want to ask, or if not, then we can just conclude the session. Okay,
Thanks.
Okay, thank you very much. Chetan, you want to say something?
Oh, thanks.
Okay, Chetan, thank you very much. Okay, so thank you everyone. And is there any UI instead of kubectl? Yes, you have something known as web UI. You can go to web UI Kubernetes. So this is a dashboard of sorts. You can install it, but you can only access it from a kind of a secured session. You can't straight away do it like IP address and this. So on this whatever node you are installing this, you have to have a secured kind of a session to it. And so this is a kind of a web UI. It helps you to have control on pods and jobs and deployments and daemon sets and cron jobs and whatnot. And it gives you quite a lot of the information about it. So this is very helpful. Maybe we can cover this also in the next session, so you guys can have an idea about it. Okay, thank you very much everyone. I hope this was helpful session for you, and we are looking forward to have more such sessions in the upcoming days, and we'll just give you a kind of notification. And like once again, we are forming a kind of a community, so you guys can also try to bring in more of such kind of developers who might be interested in such kind of sessions. So if you have any friends who are also interested to know this particular stuff, you can also call them up in this session. So once again, thank you very much, and see you back in the next meetup. Thank you. Thank you very much.
Thank you. Bye.
Yeah, thanks, Parth. It was a
Thank you,
nice
Parth.
session.
Thank you. Thank you very much.